Bit of interaction for you because it's been very us talking towards you at the moment. Greenhouse effect. When is the greenhouse effect first discovered? When did someone work out that the world is kept nice and warm due to greenhouse gases? Ballpark year for me. Go on, someone be brave.
68.
68? 1968. Okay. Anyone else?
1670.
Yeah, okay, you're getting a bit closer now. It's in 1824 when a man called Joseph decided that the reason why mankind exists on the Earth is because we have a blanket of gas around the Earth which keeps us warmer than we're supposed to be. Roughly 30 degrees warmer than we would be if we didn't have a blanket of gas. And obviously, if you took 30 degrees off the global world temperatures, we'd all be very, very chilly a lot of the time. So, greenhouse effect is critically important for us to survive. So, when did we work out that burning fossil fuels was a bad idea? Or when did we first work out, in this case, that it was a good idea? Ballpark figure again, anyone? Go on, be brave. 1880? Ah, you're getting good now. Yep. 1896. This gentleman, who was ridiculed at the time, came up with this great idea. He was very, very concerned that the next ice age was going to wipe out mankind. And at the moment, our global temperature is roughly 6 degrees warmer than it was at the middle of the last ice age. So if you warm up the planet by around 6 degrees in the middle of an ice age, you get to today's temperatures. And he worked out that if you burnt an awful lot of coal, you could double the CO2 in the atmosphere, and that would generate about another 6 degrees increase in world temperatures. And therefore, we would never have another ice age. And he thought it was a fantastic idea, and he was advocating burning a lot of coal back in 1896. Since then, we have been burning a lot of coal, but we're now noticing a different effect. However, he's been proved to be completely right. The IPCC fourth report, which is coming out at this moment, is saying that the doubling of CO2 in the world is producing a 6-degree rise in temperature, more or less. So it's going to cause some significant problems. And the topic's been around for an awful long time. Bill put up a similar one to that this morning. This just shows 6 different models. You can choose here any one of these 6 parameters, and it ends up being around about 3 degrees quite quick. This is global surface temperature over the last 1,000 years at the bottom. A sharp increase during the latter half of the 20th century and into the 21st century, and we're going to end up around this point quite easily by 2100. My personal view is that 2050 is the big one for us. If we get to 2050 without massive world instability, we're going to be doing very, very well. I'll explain why in a moment. I'll come back to payback. At the moment, the Pentagon suggests that global warming is the biggest threat to mankind's future on the planet. Not Al-Qaeda, not any terrorist organisation, nothing else. Global warming is the one biggest threat. That is due to the huge changes you're going to get across the world due to climatic changes. Bill, this morning, was on about payback, and it's a very, very good question. And he was saying that his PV cells that he was putting on the roof of the building they were designing for the National Trust, as it was not going to have a payback for 30 years, the client didn't go ahead with it. And that's because you're measuring payback by the cost to me, the client, in my pocket today versus what I might save at today's rates. If you start to measure it on global climatic problems, then payback for things like PVs about 5 or 10 years. But you have to have an agreement about how you're actually going to measure it. And the problem at the moment is that we have no carbon tax, and therefore you don't tend to get people seeing the bigger picture. I'll come on in a minute to the Stern Review, which I would recommend you all read if you haven't. It's quite a large document, so I'll recommend the Stern Review Executive Summary instead. In the UK, we're not doing very well, I would suggest. The precaution principle is used across parts of Europe, Germany in particular, where they say, OK, global warming may be a huge problem, we can't be absolutely sure, so rather than just wait and see what happens, we're going to do something now instead. The rest of the world, and I'll include the UK in that, is we're not actually being all that proactive at this moment in time. There's been various studies about the cost of going green, and if you do things like improve fuel poverty, you make a huge difference to the UK health bill, and you can save something like £1 billion a year estimated by not having people dying of hypothermia and cold and breathing disorders due to ill health due to the cold homes they live in. So a cost-benefit analysis can be done, but it depends on how wide you want to put the scope. So if you start trying to include, say, a sea level rise of 10 metres wiping out a big chunk of London, the cost of that is huge. But it's very hard to actually nail down today what that cost will be, because obviously it's got a lot of variables in it. So the Stern Review forecasted that around about 1% of GDP should be spent today to stop the amount of CO2 we're releasing. And that's quite expensive. That does have an impact on everybody's pocket, and people don't like it, and that is why at the moment we're not going along with it. However, the Stern Review also warns that you're going to displace around about 100 million people over the next 100 years, and being displaced by flooding doesn't mean you're happy about it, obviously. It means you want to go and live somewhere else that's a bit higher up. I live at 300 metres above sea level, so I think I'm absolutely spot on where I live, but obviously a lot of people are going to be walking up the hill towards me to share my home based on 100 million people around the world. Also, unfortunately, those 100 million people are mainly in areas where they're very poor and developing worlds. So again, they've got a very small voice at the moment, but the cost of rehousing 100 million people is obviously quite expensive. They also talk about melting glaciers, and ironically, melting large amounts of ice in the world causes a shortage in drinking water, which doesn't obviously make sense. But what it does is that flows into the sea level rises, and therefore you start to wipe out underground freshwater resources. They end up with salt in, which makes it rather hard. You can desalinate water, and it was mentioned earlier that Abu Dhabi, etc. are desalinating water, but that does require a large amount of energy, and you've got a carbon footprint problem from that as well. There are various studies about wildlife, and I'm a particular fan of wind turbines, big ones, on big hills, spoiling the countryside, as most people see it. But I quite like those. And there's a lot of argument about the fact the first wind turbines that went up, people were saying, you're going to kill a few seagulls. They'll fly into them and they'll kill a few seagulls. My comment was good, because that way the rest of the seagulls will survive, because global warming may not happen. And there's recently been the first underwater tidal turbine put in the Irish Sea, effectively, onto a large lock entrance. And again, environmentalists are getting very upset about seals maybe being concussed by a large propeller going around in the water. Unfortunately, if we don't do things like wind turbines, we're going to have a bigger problem with wildlife. And one report says around about 40% of every single species on the planet could become extinct. Now, I did say at the start it's going to get a bit negative. I'm going to cheer up in a moment, but that's the cost of global warming. So it's very hard to say that a PV cell on a building will pay back in 30 years, because what cost do you put on the Amazon rainforest disappearing? And that, to me, is the real cost you've got to look at, which is very hard to do. You get lots of climate refugees. And the Stern Review also said that although it would cost 1% now of our nation's GDP, which is a lot of money, if we do nothing at all, then the cost of dealing with those thousands of refugees and all the water shortages and food shortages will cost around 10 to 20%, which is a huge difference. So it's kind of thing about, pay £1 now, or in 20 years' time, pay 20 quid. Well, I'd rather pay the £1 now myself, and then not have all the other aggravation that you're going to get from this. So, there's a nice gentle image. Oh, NIMBYism, yes. Up in Scotland, in the paper yesterday, up in Scotland, they've just turned down a huge wind farm that was going to be built top end of Scotland for environmental reasons, because it's built over a peat bog, and they're worried about the local wildlife that lives on the site. And there is a risk that building those wind turbines could affect the peat and could affect those insects. My view is that 20 years from now, if you don't build any wind turbines, global warming will dry out the peat bog for you and kill off all the species anyway. So this is a quick way of maybe killing them off early by building wind turbines, but the rest of the world may well survive. So NIMBYism is a difficult thing, not in my backyard is what it stands for. So most people want to save the planet, but they don't want a wind turbine up the road. I'm a bit NIMBYism in myself. The government's recently announced that nuclear power is the way to save the environment, which is an interesting way of looking at things. But I don't want a nuclear power system anywhere in the UK. I would much rather have some nice big wind turbines, PV cells, tidal power, and other such things. So we are all NIMBYs to a certain extent. So we've had some various figures bandied about, some about carbon reduction. It's estimated by Kyoto that we needed a 12.5% reduction of 1990 levels. Europe said 15%, the UK government said 20%. Then the UK government came back with a white paper a couple of years ago saying really it's 60% reduction, and the current talk is 80% reduction in carbon. And I don't think people really understand what that means. An 80% reduction in carbon means that, 5 days out of 7, you do not switch on any light bulb, you do not switch on any TV, mobile phone, DVD, don't get in a car, don't get on a plane, don't go to work, sit at home in the dark, in the cold, saving carbon. Clearly, that's ludicrous. But if you seriously want to reduce carbon by 18%, you have to do it by conserving energy and also producing energy that has got zero carbon. That's where renewables come in. So an 80% reduction in carbon is a massive undertaking, and it is, I believe, what the UK and America and the rest of Europe need to achieve so that the world can continue turning for another 100 plus odd years. Buildings account for around about 50% of the UK's total emissions, so if we're going to tackle CO2, then one way to tackle it very easily is to deal with buildings. And the point made this morning is that we've looked primarily at new builds so far. Existing buildings make up 99% of all the stock. So whenever we build new buildings each year, they're roughly 0.5 to 1% of the new stock. So it's going to take roughly 200 years to get all the buildings built to today's standards. And today's standards aren't good enough anyway, but those 200 years we don't have. So if you're serious about reducing CO2, you have to have a methodology of actually saying that you own a building, this is how energy efficient it is, and you can now do something like it. You've got the information you need. So 80% is a massive undertaking. Domestic buildings take approximately 30% or use approximately 30% of all energy, therefore produce 60% of all the carbon. And for now, 6 months, we've had EPCs on dwellings when they're bought, and leasing is coming in at the end of this year. Most people, unfortunately, when they go to buy a new house or buy a house, second-hand house if you like, don't really care about the energy rating on the building. If you go and look at two houses, and one is band G, the worst you can get, and one is band A, the best you can get, and one's got a extra conservatory stuck on the back, then most people will go down the road of buying the one with the conservatory. They won't buy a house based on whether it's an A, B, C, D, E or G. I'm therefore a fan of massive tax rises. And you don't get popular or very many friends saying this sort of stuff, but I think the way that all of you and me would change my behaviour tomorrow, if they quadrupled the price of petrol and diesel, all of us would think seriously about getting in our cars. At the moment, we don't. We just carry on driving and using transport in that way. Same thing with flights and also buildings. So if you're going to get serious about it, you've got to tackle existing buildings, because existing buildings make up 99% of all the stock we've got, and they're going to be around for another 100 years. This building's been stood here for 100 plus years, I imagine. It's going to be here another 100 plus, probably more. You need to deal with the energy this building uses. And this building is quite an easy one to sort out, because although it's probably listed, it's got a very inefficient heating system in this particular building, so I could reduce the carbon of this building by about half by just installing a new central heating system for it. Also mentioned, I'm trying to make sure I pick up points made by the speakers, also mentioned is that at the moment, although we spend around 60% of or produce 60% of our carbon on space heating, if you make a new building more efficient on its energy use in central heating, and make it better about water heating and then tackle the light bulbs, you end up with the IT use and mobile phone charging use and all the other domestic uses we have inside buildings. They get more problematic as well, and the more efficient your building is, the worse it gets. As a rough idea about generic averages, you've got heating being the largest slice of that pie, lighting obviously being the next one. But if you reduce this by half and reduce that by half, your pie chart would be smaller, and now your computer use would be proportionately a much bigger use. And it's a fact that at the moment, if you're designing buildings, you need to take into account the energy generated by servers, and that's getting worse and worse. As computers get faster and faster, they produce more and more heat. So a large server bank produces 2.5 kilowatts per metre squared in a building. So if you've got a large amount of servers, that's producing an awful lot of energy, normally in the heart of the building, which you then have to cool. and then you use more carbon to cool the building down. And Bill mentioned this morning that he was sort of caught out a little bit by the fact it was the dishwashers, the cookers, and the IT in the National Trust building that ended up being a high energy use. That's just going to get worse and worse as we continue to use buildings in the way that we do. So, in order to tackle climate change, we have something called the EU Directive. And a number of you are probably obviously aware of this, but the EU response to Kyoto was to agree a set of standards about how we could maybe manage our buildings far better. And this is where I do get a little bit annoyed. It was published in December 2002, it was enacted in 2003. All the governments around Europe were given 3 years to agree on how to do it, which is quite a long time, 3 years, and to do things like train people to become energy assessors. However, Article 10 of the EU Directive gave a 3-year extension. If you didn't have any qualified energy assessors, which was a new profession, then you had another 3 years to train them. And our fantastic UK government waited basically 5 years and about 9 months to get around to training anyone. And my current job at the moment is training people up, charter surveyors, civil engineers, to be energy assessors. I could have been doing it about 4 years ago, but the government wasn't quite making the right noises then about how it was all going to work. And while I'm getting on the government, I'll just mention the fact that DECs, which are display energy certificates, are supposed to be in October on a building like this, will have a certificate stuck on its front door saying this is how efficient this building is. I got given yesterday the current draft of the software, which is supposed to have been out about 8 months ago. So they're not exactly on target for their October deadline. So the EU directive had 3 main aspects. Work out a means of calculating energy performance of buildings, apply minimum standards, and then tell people how good or bad their buildings are. So I'm going to talk briefly about those 3 key points. So first of all, the national calculation methodology. We have 4 different calculation methodologies in the UK. One is called SAP, the Standards and Procedure for New Buildings, for new houses. We then have, for existing houses, something called RDSAP. RDSAP stands for Reduced Data, and that means that an energy assessor can go to someone's house and say, right, it's a 1960s detached house. I can assume from that certain new values of construction and certain window sizes, and therefore I can quite quickly, it takes around about 20 minutes to do the survey you need to do for this, you can quite quickly produce a certificate to give to the building owner saying this is how inefficient or efficient your building is. For new and existing non-dwellings, which most people then take to mean commercial buildings, so that covers everything else apart from a house, so schools, shops, pubs, clubs, hotels, restaurants, museums, offices, sports centres, all those things are lumped under non-dwellings. You have 2 ways of doing it. You have something called SBEM, the Simplified Building Energy Model, which is not at all simple. It's what it's called because it works out energy on a monthly basis. It's actually quite a complicated model, but it is relatively easy to collect the data. And they have something called Dynamic Simulation Modelling, DSM, and that is a far more it's a more interesting approach, and at the moment the government's trying to decide what it means by it because it hasn't got any approved software either under Dynamic Simulation Modelling. L2A and L2B is for non-domestic new build for Part A and non-domestic existing buildings for Part B, and we brought in a new regulation, number 17 basically, which looked at how to approve methodology, set standards, meet targets and define a building. And I'll come back to defining a building on the next slide. It also changed, and this was a very important change, it also changed a number of the terminologies that are used at the moment in the building regs. So for example, they changed what we mean by a substantial alteration, basically bringing more buildings inside the regulations. And the existing approved document L2B also brought in this. Consequential improvements for energy performance of buildings over 1,000 square metres. Basically, if you have a building over 1,000 square metres and you start to change one of the walls or a chunk of the roof or a floor or anything like that, you now have to upgrade that entire fabric to 2006 elemental standards, which is a significant change, and it's making, for the first time, existing buildings have to be improved as close to we can get to current building regs. The problem with that is they then said, unless it's expensive. And what they choose as a payback calculation is 15 years. which means most old buildings like this one, you cannot upgrade the walls well for only a 15-year payback, because the 15-year payback is based upon the current value of £1, and that doesn't take into account all the global warming issues I mentioned earlier. However, it is a start, although it's maybe a slow start. So, definition for building. You'll be pleased to know this is a building. This is a structure that has a roof and walls, and we're using energy to condition the internal environment. So we're all sat in this room, it's quite pleasantly warm, so we're using energy, so that makes this structure a building. It means the M1 is not a building, it's got no roof or no walls, we don't use energy to condition it, so that's excluded. So it's not a huge surprise that buildings have roofs and walls. It is a surprise when you start looking at what they mean by this on what buildings are actually exempt from the regulations. If I have a very big warehouse with a huge electric heater that's on wheels, that's not a fixed building service. That's a portable service which I can ignore. So the energy that building consumes and the CO2 it puts out is exempt from these parts of the regulations. So there are some very big holes in it. The one I love, which is causing a lot of concern at the moment, is the second point from the bottom, where you expect a building to have an HVAC system at some point in the future, you produce your rating based on what you think it might end up with. And there's a lot of developers out there who are quite upset about that, because they currently build what's called a shell and core building. They just put up the external fabric of a building, sell it on to someone who then fits it out inside. And now they cannot get that signed off by building control without someone like me coming along and saying, oh, I think you're going to put in a 80% efficient system, and I'm going to rate your building on that. They might put in a 90% efficient system, and that's not taken into account. So there's a bit of a mismatch on buildings that are being built as shell and cores, and that's increasingly a large proportion of the market. So very simply, a building is where we're using energy to condition internal environments. It's not a huge shock. Now, the thing I do like about our government is that they make things as complicated as they possibly can. That is a domestic energy certificate. What it means is, we have two graphs on it. This graph is a nice pretty graph, which they did tests on the public, and the public said they understood that green meant more green, more environmentally sound, red meant less. And that's what they actually spent a lot of money testing, but they worked that one out. This scale goes from 100 at the top, so if you score 100, you're doing really well. If you score 0, you're doing very poorly on a G. It then has a second graph, which is carbon footprint. This is the cost per square metre of heating your house. This is the carbon you produce heating your house and lighting it, etc. So, fair enough, most people can understand that. So when the government designed their commercial energy certificate, they simplified it, and they used the same pretty colours that the public understands. Since I've just told you that on the domestic, this is pounds per square metre, you would think maybe they were using the same scale. Oh, no. This is carbon per square metre, and the scale's upside down. So where over here you've got 100 being good, 0 being poor, over here 0 is really good, and it goes to 150. So I'm currently having discussions with clients who own buildings, office buildings, and they own houses, and they cannot understand why 100 on one's really good and 100 on the other one's really bad. And it wouldn't have taken much of the government to get that right, but that is a slight oddity in the EPC market. There's also a third kind of certificate called a DEC I'll come to at the end. So that's just an enlargement of that main scale, and it's the same when you get on fridges. So for example, the green to red scale, you can now go and buy a new car, you can buy a fridge, freezer, washing machine, all the white goods, have those things stuck on them by law. And most people will go and buy an A-rated washing machine because it means you spend a lot less running it, uses less water, less energy. And the same is true if you buy a house that's A-rated, you should end up spending a lot less money on your fuel, and that means you produce less carbon. I'm going to do some research. I haven't got round to it yet. It's one of the problems about doing consultancy work. But I want to do some research looking at people who bought a house 6 months ago that was maybe a D and E, well actually no, maybe it was E, F and G, and find out what they spent their money on since they moved into their house. Without doing any research, I'll bet money that they all bought patio heaters that burn colour gas. They put decking down, maybe from a non-sustainable resource, maybe it was. They probably redecorated a perfectly well-decorated house, and they probably put a conservatory on the back. I don't think any of them will have installed a new system of heating control on their boiler, because it's not quite top of the list when you come to DIY type jobs. So the problem with domestic EPCs is you give someone moving into a house, here's your certificate, and they put it in a drawer, and that's it. Nothing happens. I'm lobbying the government at the moment, just for fun I suppose, but I'm trying to make it that in the future, and it's being discussed by government at the moment, trying to make it in the future that if at the moment you pay, let's say £1,000 a year council tax, and your building in the future is rated as a G, you will pay £4,000 in council tax. Whereas if you've got an A-rated building, you will only pay 50 quid a year in council tax. I think if you do that, one, it will upset everyone who owns a house, but it will also mean that they will suddenly go, hang on a minute, that means if I install some loft insulation, I actually pay less tax. What a good idea. And they'll go and do it. It basically means you make the payback 5 times as good as it was originally. So that's an interesting... The government is considering it, along with weighing wheelie bins for your rubbish and your recycling. This is the way we're moving. We have to move, because people will not change their behaviours unless they're poked repeatedly with a sharp stick. Commercial EPC, I've mentioned already, looks like that. One of the fascinating things for me is that the 60 number there is produced from a calculation which makes no sense at all to most members of the public or owners of buildings when you explain it. And recently the government halved the scale for no apparent reason. It used to go from 0 to 100 to 300%. 6 weeks ago now, they just quietly changed the scale from 0 to 150 and made all the numbers a lot smaller. I don't understand why they did that, because the letters stayed the same. But it was an interesting tweak the government did. So, down to the nitty-gritty. If you have a new building that you want to put up at the moment, it has to meet a carbon target. We don't any longer use individual U values for building elements. Generally speaking, in 2006, the regulations changed to say all we're bothered about is the total carbon coming out of your building. If you want to build a fully glazed house, as long as you put enough insulation in the roof and in the floor and maybe have a ground source heat pump, your carbon footprint will be okay, it will be low enough to be okay. So you have your building emissions rating, which is the actual carbon produced by the building, and you have a hypothetical target emissions rating based upon, effectively, 2002 U values reduced by around about 30%. And the way that building regulations will change in 2 years, 5 years, and probably another 5 years after that, all we'll do is leave the 2002 U values where they are and make the reduction 20%, 50%, 80%, 100%. And when you get to 100% reduction from 2002 levels, you have a zero carbon building. The government is committed to having all new homes zero carbon by 2016, which is going to be a very interesting target to see if we hit that. And they've also just announced that all commercial buildings need to be zero carbon by 2019. And I don't think we stand a hope in hell at the moment on getting to that point. We need to, but again, that will only deal with the 1% of buildings built every year after that. It won't change the 99% that still stood up using a lot of energy. So the EPC for an existing building has both the BER and the TER, but also these other names. They have the TYP, which is the typical emissions rating. So that should say TYR, apologies, I should change that. TYR, which is the emissions rating, the SER, which is the standardised emission rating, and they produce an EPC by dividing the BER, the actual building's emissions, by the standardised. And the standardised is roughly about a 23% reduction, again, from 2002 standards. That then gives you a number. That number is now divided by 2, and that is the figure that goes on your EPC. So it's not clear how it relates back to carbon exactly, but it's to do with setting targets for buildings and then trying to achieve those targets. So if you're going to describe a building or produce an EPC using SBEM, which is the commercial market at the moment, you have to do this. Describe the building, you have to explain, for example, this is a very large hall, it's got a very high floor ceiling, it's got some windows up there, how big are the windows, they're single glazed, what insulation's in the roof, there's clearly ventilation through up into the roof void. All those things need to be described. You also have to tell it about the activity. So this is an assembly hall, obviously, so this is a room people sit around in with people like me up front talking. If this was an office, it would have a different energy requirement. If it was an IT data centre, you would assume 24-hour-a-day loadings of computers and phones and things like that. So the activity makes a real important contribution. You then need to work out an approximate U value for various elements and also things like glazing and thermal mass. And then you take into account the heating, ventilation and cooling system, so the HVAC system, also lighting, and you need to describe the type of HVAC it is, whether it's a central heating system or air conditioning or mechanical extraction, and then what the efficiency is. And the efficiency of heating can go from 40% up to 95%, so you get a huge variation. One of my favourite little ones to throw in is the fact that the old coal fire that we had in Victorian homes in particular was around about 30% efficient. When 20 years ago we produced the coal effect gas fire, that was 20% efficient. We managed to make something modern that was 10% less efficient than the old coal fire. We now have done things like put glass in front and sealed it to the chimney and things that's made it more efficient, but the seasonal efficiency of your heating is critically important. Finally, you've got controls. If you have a programmer, a room stat, TRV, zone control, all these other control systems, you improve your efficiency of your system, and by improving your efficiency, you reduce your carbon. So SBEM then calculates the monthly demands for heat, ventilation, cooling, lighting and hot water in the building you've just described. It bases it on the geometry of the building, the construction, the activities you told it, and it then works out, based on the efficiency of the system, how much carbon is being required to power this building. And that then ends up being the BER, and it works out the remaining calculation for you. The timetable for EPCs, the remaining timetable in a way, 6th of April we brought in it for all new dwellings, and buildings over 10,000 square metres also required it from the 6th of April, although the government did do a little bit of a delaying tactic with that one. Basically, October's the key one. By the time we get to the 1st of October, every new building, or when it is sold or leased, will require an EPC of one kind or another. In addition, you have something called a DEC, a Display Energy Certificate, also known as a DEC, for all public buildings. The DEC is very different. An EPC is based upon assumed heating. A DEC actually uses the fuel bill that the building has. So they're not the same, and again a DEC looks different to an EPC and is worked out in a different way. So as you can end up with buildings with both DECs and EPCs, it doesn't really help either. So that's the third kind of certificate we'll see from October in particular. That's a DEC. So for public building, the same sort of graph over here, and it's the same scale, which is good news, is a commercial EPC. And then it's got this one about carbon, and then this one here also shows you it's a 3-year certificate. So the first year you do it, there's only the one graph. The second year you have to add on last year's figures, and the third year you add on the last 2 figures. It's a rolling 3-year. And that should show you in that bottom corner that the building was a band G. They've reduced their energy and they're going up and up and up, and that's the intention. Again, as I mentioned before about houses being linked to council tax, I think the way the government's got to go is to turn around and say, right, business rates. If you are running an office building, you pay X amount of business rates. If it's band G, in the future you'll be paying 10 times as much business rates. If you've got an A-rated building, you can pay a lot less. That is the only way people will start to really make a difference about the energy they consume. So, that's basically it. I think there's one point I wanted to pick up on from earlier on, which I'm going to forget now. That was it. It's just going back to the 80% reduction. So going back to the 80% reduction argument, by producing EPCs, it's lovely. Icons go around sticking multicoloured pictures on buildings. And those people with that EPC do not need to do anything with it whatsoever. There's no legal requirement to do anything with it. So the government will say, it's a carrot. We're giving people the opportunity to amend their behaviour. My response to that is, well, we've had about 50 years' worth of people not doing anything about energy. What makes you think they're going to change now? Which is why I think they've got to link it into taxes. Otherwise, it's not going to make much of a difference. So, I shall stop there. Happy to take any questions, though, unless I've depressed you all.